In this video tutorial, we solve a few problems related to finding rational numbers between two numbers. Now, we have already covered the theoretical portion of this topic or discussion. If you haven't watched that video tutorial, I request you to please first watch that video and then come to this tutorial and watch it. I'll put the link to that tutorial in the description below. Anyways, let's start. We have two numbers, -2 and -1. Let's write it here, -2 and -1. First, I'll explain you without using number line, and then I'll explain you using number line. Okay, this is -2 and this is -1. Is there any other integer possible between this -1 and -2? No. So, imagine that there is a road between these two destinations, and the two destinations are -2 and -1. Okay. How many rational numbers you have to find between these two integers? 5. What you do is you break this road between these two destinations into 6 equal parts. So 1, 2, 3, 4, 5 and 6. 1 part, 2 part, 3 part, 4 part, 5 part and 6 parts. Before proceeding on, let me tell you one thing. As we have learned in the theoretical video that you can have unlimited number of rational numbers between two given numbers. So your answers may vary from each other, okay, from one another. So don't think that your answer is wrong because maybe the other person is following some different way to calculate the answer. So your answer can vary because you can have unlimited number of numbers. In this question, we have broken this road between these two destinations into 6 equal parts because we want how many rational numbers? 5. So each mark, 1 mark, 2 mark, 3 mark, 4 mark and 5 marks, this will be the 5 rational numbers. So that's why I have broken this into 6 parts. Okay. Now, before proceeding further, what you have to do is, this is -2. Can we write it in the form of a rational number? This can be written as -2 over 1 and this can be written as -1 over 1. Okay. Since we have broken this into 6 equal parts, what you do is you multiply both the numerator and the denominator by 6 and you get -12 over 6. Now notice that this -2 over 1 is actually what? -2 only, and since we have got this -12 over 6, we have reached to this point by multiplying 6 to this rational number. It means that these two numbers are actually equivalent rationals, the concept of equivalent rationals. Similarly, you do the same thing for here. -1 times 6 and 1 times 6. What do you get? You get -6 over 6. This rational number, that is -1 only, and this rational number, these two are actually equivalent rational numbers. So you should know what are equivalent rational numbers. Anyways, so this -2 can be written as -12 over 6. So I'm writing it as this one only, as -12 over 6, and this -1 can be written as -6 over 6. Okay, now this 6 tells us that this has been actually broken into 6 equal parts. Now we have 5 these marks which will tell us the 5 rational numbers. Now focus on the numerators. What is numerator here? -6. What is numerator here? -12. Okay, so this will be -7 over 6, -8 over 6, -9 over 6, -10 over 6, and -11 over 6. So 1, 2, 3, 4 and 5. We have 5 rational numbers and those are here. Now you can see that some rational numbers can be further simplified. Like, do we have any common factors between 7 and 6? No. Do we have any common factors between -8 and 6? Yes. The common factor is actually 2. So if you simplify it, if you divide this 8 by 2, okay, just put minus sign as it is, divide 8 by 2, you get what? 4. Divide 6 by 2, you get 3. So you can simplify it. Even if you don't simplify it, your answer is not going to be wrong. That will remain the same. I just tried to explain you that you can further simplify your answer. Okay. For those of you who are thinking, why only 6? Can't I break it into 12 pieces? Boss, you can break it into 100 pieces, in the 1000 pieces. That's why I'm telling you there is no fixed answer to tell how many rational numbers will come between two numbers. It is unlimited. Think of it as a universe. It's vast. Okay, it's unlimited. Okay, that's the beauty of rational numbers. Okay, same thing is for 0 and minus 1 actually. Same thing. Think of it as two destinations. This is minus 1. This is 0. So how many rational numbers you have to find? You have to find 5. The same thing here, as we have broken this into 6 equal parts so that we can get these 5 marks. 5 marks means it will divide this destination into 6 equal parts. So same thing here, divide it 1, 2, 3, 4 and 5 marks means 6 equal parts. Though they are not looking very equal, but assume for our discussion that they are actually equal. Now, same thing what we have done here. This minus 1 can be written in the form of a rational number, that is minus 1 over 1, and this can be written as 0 over 1, because we can divide any number by 1 and we'll get back that number only. Now, same as we have done here, so this is minus 1 over 6 and this is 1 over 6. This becomes 0 times 6 and this becomes 1 times 6. What do we get from this? We get minus 6 over 6. So this minus 1 over 1, that is nothing else but minus 1 only, and this minus 6 over 6 are actually equivalent rational numbers. So this minus 1 can be written as minus 6 over 6 and this can be written as 0 over 6. So this 0 over 1, that is nothing else but 0 only, and this 0 over 6, these are actually equivalent rational numbers. So this can be written as 0 over 6. Okay. Now focus on numerators. This becomes 1 over 6. This becomes, minus 1 over 6. This becomes minus 2 over 6. This becomes minus 3 over 6. Minus 4 over 6. And this becomes minus 5 over 6. And then comes minus 6 over 6. So we have these 5 rational numbers between these two integers, that is 0 and minus 1. Okay, again, can we have any different answer from this? Of course you can have. Break this destination into 1 lakh parts. Who cares? But that will be tough to find answers. You can break even into 12. Okay, you'll get some different answer. Now, what we have done here is actually exactly what we'll do in the case of number line. And the only reason that I am explaining you using number line, so that you can understand that why we have done actually this thing. Okay, so that you can relate to it. Okay, so let me draw it here. Let me take a number line. I'm not going to write the positive integers on this on this number line, because we don't have to use it. So just focus that our 0 starts from here. Let's say that 0 starts from here and our minus 1 comes here and our minus 2 comes here. We know that to the left of 0 are actually negative integers and to the right of the 0 are actually positive integers. Okay, now 0 and minus 1, minus 1 and minus 2. First take this 0 and minus 1. So this 0 and minus 1, you have to find 5 rational numbers. You'll do exactly the same thing what we have actually done here. Since you have to find 6 rational numbers between these two, think that you are actually going to divide this into 6 equal parts. 6 equal parts, why? Because in that way you will get this 5 marks, right? This 5 marks will be the 5 rational numbers. So you have to think of these numbers as having their denominator as 6. So in order to make the denominator, first you have to follow this path, that you have to make them the rational number, and then this path you have to find the equivalent rational having the denominator as 6. That 6 what will give you actually what these 5 marks, right? So divide this into 6 parts and then divide into 6 parts, and you'll get what? Same thing. You'll get 0 over 6 here. You'll get, for -1 you'll get -6 over 6. Can you see that here it is -6 over 6 and here also it is -6 over 6, same thing, right? And then -12 over 6. This is actually a number line, and whatever we have done here exactly the same thing here. If you divide this into 6 parts and this into 6 parts, you'll get all these numbers only. Okay, now let's solve these two problems. Same thing here. In this case, you have -4 over 5 and -2 over 3. Whenever you are dealing with such situations where you have actually two rational numbers, but they don't have the same denominator. First, you make these two rational numbers, convert them into the rational number such that they have the same denominator. And for that, what you have to do is, what's the denominator here? 5. What's the denominator here? 3. 5 and 3. Find their LCM, least common multiple. Least common multiple of 5 and 3 will come as what? 15. Okay. Now, convert this -4 over 5 into an equivalent rational number such that its denominator is 15. So in order to make the denominator as 15, what number we should multiply 5 with so that its denominator becomes 15? The answer is 3. Now since we have multiplied the denominator with 3, we also have to multiply the numerator with 3. The concept of equivalent rational numbers. This gives you what? -12 over 15. Now this one, you have to convert this rational number in a way that its denominator comes as 15. So by what number we should multiply 3 with so that its denominator comes 15? That will be 3 times 5. Focus on this 15 only. So since we have multiplied the denominator with 5, you have to multiply the numerator also with 5. So this gives you -10 over 15. Now you can see clearly you have actually these two rational numbers. This is equivalent rational number of -4 over 5, and -10 over 15 is actually equivalent rational number of -2 over 3. Clearly the denominator is actually same. It's something similar to what we have learned in the case of like fractions, right? Though these are not fractions, but the concept is the same, that always keep the denominator same so that it's easy to compare, it's easy to find the numbers. Now, think that these are two destinations. So, of course, -10 over 15, the denominator is are same in both these two numbers. Which one will be the greater number? As I have told you, whenever you compare the two rational numbers, if the denominators are same, then you just look at the number which has smaller value with the negative sign, that will be the greater one. So this is -10, this is -12. Of course, -10 is greater than -12. So let's put it towards the right, because we know that on a number line, the greater number comes towards the right only. So let's say this destination is -10 over 15, and this is -12 over 15. Now if you simply what we did in our earlier problems, if you focus on the numerator -10 and -12, in that way you can have only -11 over 15 in between that. That's not going to work, okay, because we need 5 rational numbers. What you do is first take this one. This is -12 over 5, -12 over 15. You multiply both the numerator and the denominator with 2. Multiply this with 2. What do you get? You get -24 over 30. Again, -24 over 30 is actually equivalent rational numbers of -12 over 15. Because if you simplify it, because if you divide this 24 by 2, what do you get? 12. If you divide this 30 by 2, what you get? 15. So the number you are multiplying with, if you divide the same thing here, you get back this number only. That's why it's equivalent rational number. Same thing here. This is 10 minus 10. Let me take some different color. This is minus 10 over 15. So we have to keep the denominator same. So we multiplied with 2, multiply this with 2 and 2. This gives you minus 20 over 30, right? It gives you minus 20 over 30. Now, minus 20 over 30 is equivalent rational number of this minus 10 over 15. So now we have minus 24 over 30 and we have minus 20 over 30. Again, look at the numerators. What all numbers you'll get? You'll get minus 21, minus 22, minus 23, minus 24. Again, you are short of one more rational number. We have only 4. So what you do next time is remove it and now multiply this minus 12 over 15 with 3. Just replace this 2 with 3. So your answer will come different in this case. With 3, 3 and 3. You get minus 36 over 45 and minus 30 over 45. Now that's better. Now you can have 5 numbers, exactly 5 numbers. So this minus 12 over 15 can be written as this equivalent rational number, that is minus 36 over 45, and this minus 10 over 15 can be written as an equivalent rational number of minus 30 over 45, right? Now focus on the numerators. So you will find what? Let's take a different color. Here comes minus 31 over 45, then comes minus 32 over 45, then comes minus 33 over 45, then comes minus 34 over 45, and then comes minus 35 over 45. So 1, 2, 3, 4 and 5. We have these 5 rational numbers. Okay, let's take this one. In this case, again, what you have to do is first make the denominators same. So LCM of 2 and 3, we get 6. Now you have to find equivalent rational number of this rational number in a way that it has 6 in the denominator. So by what number we should multiply 2 with so that the denominator becomes 6? Clearly by 3. Since we have multiplied the denominator with 3, you have to multiply the numerator also with 3, and you get minus 3 over 6. Even in this case, by what number we should multiply 3 with so that we get denominator as 6? Clearly by 2. So you have to multiply the numerator also with 2. This gives you 4 over 6, right? Now, this is 4 over 6, this is minus 3 over 6. Look at this number very carefully, it's actually positive. One positive, one negative. In this case, we had both the numbers positive, negative, but here we have one positive and one negative. Okay, so this is equivalent rational of this is equivalent rational of 2 over 3. Now, same thing, think of it 2 destinations. One is here, 4 over 6, and one is here, minus 3 over 6. Okay, focus on the numerators. This is 4, this is minus 3. Clearly, if you think of it as a number line, so when we move towards the left, the value goes on decreasing. So this becomes what? This becomes 3 over 6, this becomes 2 over 6, this becomes 1 over 6, this is 0, or you can write it as 0 over 6, because you divide any number, divide 0 with any number, you get back 0 only. This is minus 1 over 6, and this is minus 2 over 6. Okay, can we get 5 rational numbers? Clearly, because the two destinations are here, and we can have 5 rational numbers, 1, 2, 3, and then either you can write 0 over 6 or simply 0. So we have total how many rational numbers? 1, 2, 3, 4, 5 and 6. You can choose any 5 rational numbers, and you can further simplify some of them, like it's 3 over 6, this can be written as 1 over 2. This is 2 over 6, this can be written as 1 over 3. Similarly, this can be written as minus 1 over 3, right? So you can even write this one also, but again, even if you write this minus 2 over 6, it's not going to make any difference.